everyone, Tim here, and today we're going to be going over how to solve the Fibonacci sequence iteratively. So we can solve this either iteratively or recursively. Today we're going to be going over the iterative method. So this is targeted specifically for the virtual whiteboarding environment. So if you are going through a whiteboarding interview, or code challenge is what some people call it, and say that the individual giving you this problem tells you that they want you, given the nth number of the Fibonacci sequence, they want you to return that value. So we would want to go right off the bat and write that down. So given the nth number of the Fibonacci sequence, return the nth value. Now this is where you want to ensure that you listen to everything that they say and ask clarifying questions. If they aren't obvious to you, ask them, because you don't want to be into your algorithm and possibly write something wrong. So right off the bat, if you do not know what the Fibonacci sequence is, that's what you're going to want to ask them. So what is the Fibonacci sequence? The Fibonacci sequence is, of course, a mathematical sequence created by a mathematician, and it's also something that occurs naturally in nature for things such as like a sunflower seed. So what the Fibonacci sequence is the nth number is the previous two numbers added together. So in mathematical form, it is simply n is equal to n minus 1 plus n minus 2. Now, so looking at this, say that we're trying to find the third value in here. We're going to need to know the first two to base everything off of. So that's likely another question that you're going to want to ask them is, okay, with that being said, what are the first two values? So the first two values of the Fibonacci sequence are 0 and 1. So for a little bit more understanding here, I'll write out how the Fibonacci sequence actually goes. So first number is 0, and 1 is right after that, as we stated before. So then that means that our third value here is going to be 0 plus 1, so 1. The value after that is going to be 1 plus 1, so 2. Value after that is 1 plus 2, 3. Value after that is 2 plus 3, 5, 8, so on and so forth. And that is the Fibonacci sequence in essence. So it's going to continuously get larger and larger based off of the previous values. So now that we know what the Fibonacci sequence is, what the first two numbers are, we can start thinking about our pseudocode. And before we do that, we want to actually clarify a little bit and say with the interviewer, so say that our input is 3, then what would our output be? So looking at this, mathematically this is going to still start off as 0, so it's going to be 0, 1, 2, 3. So if we get an input of 3, our value should be 2 that we return. So this is where we would ask our interviewer, so if you give me 3 as the input, you want the output to be 2, correct? At this point they're going to say that is correct, so then we're going to go ahead and work into our pseudocode here. This is going to allow us to think about it, see if there's any better ways to do this. So there are a couple ways. We can either use 3 different integers, one that's going to hold the first two numbers right off the bat as the result and the next result, and then we can have a temporary integer within our loop or outside of the loop, for this case inside the loop, that will return it. Or we can go ahead and do a list and actually have all these numbers in the list and base it off of these numbers. So for this case, we're going to do the 3 integer approach, since that is one of the more popular approaches to do this. So we are going to go and say that we're going to create an int to hold the result. And then we are going to create an int to hold the next result. All right, and now we're going to have to go through this iteratively. So for this case, I'm going to use a for loop. we're going to use that to calculate the nth value within the Fibonacci sequence. And we are going to do that based off of the input. Now within that loop, we are going to create a temp int to hold the result. And then lastly, actually not lastly, so we're going to create a temp integer to hold that result value. And then we're going to shift the next result over to the result. So we are going to assign the value of next result to result. And then we are going to calculate the next result based off of the temporary number, which was our old result, and the next result. Since our next result is still going to be, we haven't changed it at this point. So for our next value, the result and the next result are actually going to be our value after it. So then lastly, outside of that loop, we are going to want to go and return the result. Now looking at this, this may not exactly make sense with the flow when I go through the code. I hope it does. I'll try to walk you through it and explain every part of it. And this is where we really want to look at it and say, given 3, with this logic, are we going to be able to return 2? And is there anything that we can do? So say that we had an extra loop in here or unneeded integers. At the moment, since we only have one loop, our time complexity is going to be O of n, since n is the input value right there. And what that really means is that our loop, so the time that it takes, is going to be as long as the input number. Okay, and so we would want to minimize any extra loops if we had any, and then we would also want to minimize that space complexity by eliminating any other values that take up extra space, such as our integers. But with this method, we do need those 3 integers. So now for our actual code, we're going to want to create our signature. So we're going to do public static. The reason that we're doing this is so it will be able to be seen and accessed from anywhere within the program, and static, so you can call it from a static method, and also so that you don't have to instantiate the class that is within, so the object, to actually call this. So you can just call it by class name in the method. So now we're going to do the return type. So integer is the return type, and then we're going to give it a name. So since it is public, we're going to be using the Pascal case. So we are going to say calculate, whoops, if I could type here, calculate Fibonacci. And as we were told by the individual giving us this, we are going to be passed in the nth number. So we'll say int n. Now we're going to do our curly braces, and we want to make sure to close these off right off the bat just so we don't forget later on. And we're going to pretty much go through our pseudocode at this point. So we're going to create that integer to hold the result. So we're going to do int result is equal to 0. The reason why we chose 0 is this is the very first number of this Fibonacci sequence. So if right now I just said, hey, I want you to give me the 0, n is equal to 0, and I pass that in, it's going to return 0. Now we're going to need to do the next integer value, which we are going to call next result, and we're going to equal that to 1. So right off the bat right there, we have our first 2 numbers within the Fibonacci sequence that we're going to use to calculate the rest. Now we're going to create that for loop that we also stated up there, and we're going to do int I is equal to 0 for our first part of our for loop, and then for our condition, we are going to do while I is less than n. And then we're going to do I plus plus, and I'll walk you through exactly why we're doing that. And then we're going to create and close the braces here. And for this, we're going to go and create that temporary integer. And we are going to equal it to result, as we said in our pseudocode. And then we're going to equal the result to the next result, as we stated in there. And then the next result, how we said that we're going to calculate it, we're going to equal it to the temporary number that is currently holding our old result. And then we are going to add that with our next result. And then lastly, we are going to return result. Now at this point, this may not really make sense. You may look at it and be like, okay, you said a lot of things, but that doesn't really help me. So I'm going to try to walk through why we chose all these individual elements and how it's actually functioning. So as we stated before, if we're past 0, we're passing the first number within the Fibonacci sequence, which is 0. So let's go through that case first, and I'll show you why we have it in this setup. So if we're past 0, the result is 0 right off the bat when we go into this method. So if n is equal to 0 and I is equal to 0, I is not going to be greater than n, so it is not going to execute this loop at all, and it's just going to return our result, which is exactly what we want because it is 0. Okay, so now say that we are past 1. So the second number, which is 1 in the Fibonacci sequence, so it's going to go in, set the result to 0, set the next result to 1, and it is going to assign a temporary integer in here as the result. So now our temp is equal to int. Okay? So now this is 0. Our result is equal to our next result, which is 1. And our next result is calculated based off of these two numbers that we have. So now our next result is actually going to be 1 again, since 0 plus 1 is equal to 1. So as going through, it's going to assign this the value of 0. It's going to assign the result, the value that was in our next result, so 1. And then it's going to calculate the next result based off of these two values. So as it comes in, if n is 1 that we're passing in, it's going to iterate through this only once, since we're starting off at 0 and we're doing it while it's less than n. So it's going to iterate through only for 0, and then once this comes through and increases I, it's not going to ever execute again. So it's going to come in, and it's going to do int temp is equal to the result, so 0. It's going to shift that next result over to the result, so 1. So now our result is 1, and then it's going to calculate the next one. So it is going to do the 0 plus 1 is equal to 1. And then it's going to return the result, which we shifted the next result over to the result, so 1. Okay, so now let's go for, let's say, an input of 4. So I'll remove these to walk you through it. So now if we have an input of 4, so if we do that, then n is going to be 4. And I is going to be 0 right off the bat. So we're setting the result integer and the next result integer to those first two numbers because that's what we're basing everything off of. And we are going to set the temporary integer to the result. So 0. And I is still 0. And now we're going to go and set the result to the next result. So now this is going to be 1. And this next result is going to be calculated based off these two numbers. So it is going to be 1 also. Now as it goes through and it sets those values, now I is being increased. So now I is equal to 1. So now it's going to go through and do the same exact thing again. So it's going to come in, and the temporary integer is now equal to the result, which is 1. Our result is now equal to the next result, which is still 1, so we're going to leave that right there. And now our next result is equal to the temporary plus the next result. So 1 plus 1 is equal to 2. So if we stopped right now, we are just going to go and return that one. But we're going to continue. So now it's going to go through the loop and add to I once again. So now I is equal to 2. And it's going to iterate through this. So when we come in, we're setting the temporary integer to the result, so 1. And then we are setting the result to the next result. So now our result is equal to 2. And then our next result is equal to the temporary integer plus the next result. So our temporary integer is 1 plus our next result right here. So now our next result becomes 3. Now we're going to go through the loop again. I is now equal to 3. And it's coming in, setting our temporary to 2, setting our result to the next result, so 3, and then setting our next result to the temporary value right here, plus our next result, so 3, so now this is 5. So then it's going to come through the loop once again, add to I, so now 4, so now I is no longer less than 4, and it's going to break out of this loop, and it is going to return the result, which is 3. So now if we come up here, so the fourth element, so 0, 1, 2, 3, 4 is 3. And then we can go into a little bit larger or a larger number if you had enough time, and really go a little bit more, I'm not going to say in depth, but you can iterate through this more if you wanted to. I hope that that helps you to understand how all of this works. If you would like us to go over any more algorithms, go ahead and drop a comment or contact us directly if you do have us on LinkedIn or anything like that, and we will do our best to help you out. Thank you.